So you say that that's the value of Z. So you know now the value of Z. So if you know the value of Z, we go for the fifth step of solving our problem. Fifth step, we say that now we can compute it. We can compute the population, the estimate. Compute the estimate of what? Of population mean. Population mean. So to compute the estimates of population mean, we say that the estimate of population mean from the formula, this is equal to mean that will be given in the question, and then you have Z at a half of the significance level, then you have standard deviations of population over square root of sample size. So with this estimate, we say that the mean is 10.5 plus or minus Z is 1.96. Then multiply what the standard deviation is 9, and then divided by what? Square root of 16. So the estimate population mean will be 10.5. The square root of 16 is 4. Then you do multiplication here, and after multiplication, you find the value of these fractions. So when you do well your computation by using your scientific calculator, you'll find also this part is 4.41. So therefore we say that the estimate of population mean, the estimates of population mean is 10.5 plus or minus 4.41. Okay, that is good. So now you can solve any related problem to the problem that I've told you. So this, the estimates of population mean is 10.5 plus or minus 4.41 at the response. So that's all about determinations of what? Of confidence interval. Confidence interval, estimate for a population mean when the variance is known. So let me take you to the next part, which is 6.5. And this 6.5 we call the confidence interval estimate. Confidence interval estimate for estimate for population mean, for a population mean. For population mean when variance is unknown. So when variance is what? Is unknown. How do we compute it as engineers? So I would like to teach you how we can compute the confidence interval estimate for a population mean when variance is unknown. Before I told you how we can compute the confidence interval for a population mean when variance is known. So in this case we have two cases now. So you have to know that we can draw a large sample, and the large sample, the sample size should be greater than or equal to 30. And also you can draw the small sample where the sample size is less than 30. So we have different approach in those two scenarios, right? So you said that there are two situations describing unknown variance. Statistically, there are two situation describing what? Unknown variance. And here we can find that sometimes you can have two populations, unknown variance, right? And these are, the first one, we call it large sample size. Means we can draw a large sample, right? Large sample size, and this large sample size in engineering and mathematics and even scientific mathematics, we define that the sample size should be greater than or equal to 30. And hence you have the small sample size. So the small sample size. So the small sample size, we say that this is when the sample size is greater than 30. No, it's less than 30, excuse me. Opposite of that one, less than 30. So let us start dealing with large samples. Firstly, where the sample size is greater than 30, and then we see that how you can find the confidence interval estimate for a population's mean when variance is known. So in large samples, we can have two cases, when variance is known and when variance is unknown. And for the small sample size, also we deal with that case later. Okay, even in the said lecture, etc., etc. So we come to, we say that a large sample, that is 6.51. Large sample, say large sample. So the way that problems has been solved is quite different from how I solved it. Large sample size. Large sample size. So what is large sample size? So if the sample size is large, the unknown population variance, the unknown population variance, the sample is large, the unknown population variance is replaced by the sample variance. So you say that if the sample size is large, the unknown population variance is replaced. So you replace it. It's replaced by the known population variance. Expressed by the known sample variance. Expressed by known sample variance. Expressed by known sample variance. At the point. So we can replace it by known sample variance. The distribution that we use in this case used in this interval estimate is still, we don't change, is still what? Is still the distribution. So when we're dealing with a small sample, then we can change the distributions into the student's T distribution. Right? It's still there. The formula now for the confidence interval estimate for the mean is still the same. So we say that the formula used to compute the sample variance, the mean, the population mean. So we say the population mean when the variance of the large sample, is unknown, which is equal to the variance of population is unknown. This formula is given as what? So we say that the population mean, estimate population mean, this is equal to the statistical mean, still the same formula, plus or minus Z at the half of significance level times standard deviation over square root of 40 of sample size. So the formula is still the same. So nothing new there. So in any case, in case we given the problems, for example, that the example one that we did is all about the largest sample, right? The variance there is known, but we can have a similar situations. We know the variance, we don't know the variance, but we can compute it, can compute the estimate of population mean. Very interesting concept. So again, in the previous concept, in another concept that you have to cover, I have to teach you how we can estimate estimations of the difference between means when population variance are known. So you have two populations. We draw the first sample and the second sample. We may use the two samples to estimate what the population mean, right? And then so you can deal with the sum, can find the difference between the means, and also you can find the sum of the two means. So remember that in the previous chapters I've taught you a lot about that. So this will be 6.6, so the next concept. That estimation, I'll be teaching about estimation. Estimation of difference. So estimation of difference. Estimations of difference between means. Between means. Between means when population variance. When population variance is, or population variances, when population variances are known. So we'll come back in the said lecture of this module or of this course, called the module or course. These modules of this course will discuss a lot about this confidence interval estimate for a population mean when variances are known. But now, let me teach you about the estimation of the difference between means when the population variances are known. So, in order to establish the relation for this case, we say that let x representing one population and y representing a sample drawn from the second population be two normally distributed random variables, normally distributed random variables, representing two populations. Representing two populations. Representing two populations, and let nx and ny nx and ny be respective sample sizes. Be respective sample sizes. Be respective sample sizes. Be respective sample sizes. So you have two populations and we draw two samples, and then we want to estimate what the population the mean or the difference between the means. So you have the two samples, respective sample size. Then we say that, so it means that suppose, so what do we mean here? We have, let's say, the population 1. So you have population X, and also we have a second population. We call it, let's say, population 1. So we can draw the sample here. So sample of population 1 of population X, or sample drawn from population X, and also you can do a sample here, and this will be sample drawn from what of population 1 of population 1. So what do we mean? What do we need? We need to find the difference between what? Difference between means of the two populations. So I say that now the formula for significance level means 1 minus significance level, or 100, 1 minus significance level, 100 confidence interval, estimate for the difference, for the differences, or for the difference between means, which is mean of X or mean of sample X minus means of sample Y. This one is given at this, but we say that estimate between means, estimate between means, estimate between population means. This will be given as the mean of first population minus the mean of second population plus or minus the standardized value at its relative significance level, which is alpha over 2. And then we multiply by the standard deviations of difference between means. So x minus y. This is the formula. This is the format of, this is the one format of the form. But we say that the standard error or the standard deviation, the standard deviations of means of sampling distributions of means of the difference is given by this formula. Hence we find a general formula right now. So you say that, but standard deviations of x bar minus y bar, this we learned in previous chapters. This is equal to standard deviations of the first population square over sample size x, and then plus standard deviations of 40 of the second sample size over ny over its sample size. So simply it means that this is the variance of sample x over sample size, and then this is the variance of sample y over its sample size. So it means that generally we say that the estimate, the formula for estimate of difference between means. So this now is given as what? The mean of first population and the mean of second population plus or minus z at significance level alpha over 2, and then here you have square root first variance of population x over sample size nx plus what? Second variance of population y over sample size ny. So this is the formula. So got the formula, right? So if that's the case, what do we say that? Have to go, for example, for this example, called example 6.4, or it's example 2. And then let's leave it here, the homework for you, because I've told you everything. So this will be the homework. This is homework 1. And this homework 1 we treat as example 2. So we treat as example 2. So the question states that random variables x and y, so random variable x and y are normally distributed. So these are normally distributed with standard deviation. Standard deviations of what? Of x is equal to what? 1.2. Make sure that you do it before lecture 3. And standard deviation for y, This is equal to 0.9 because I should leave the homework for you to try and check if you've understood. So you have what? Random samples, observation. So random samples, observations. So you have random samples, observation. And the first random sample observations is mean for population X is equal to 4.1, and mean for population Y is equal to 3.5. We have a full stop. At full stop, we say that full stop, say let's make the difference between population means between populations means population means by means of a 95% confidence interval. Well, that's the end of second example. Let me read it clearly so possibly some of the letters are not visible. So this is the homework you want. Make sure that you do it, practice yourself. Random variables X and Y are normally distributed with standard deviations standard deviations of random variable X is 1.2 and standard deviations of random variable Y is 0.9. Random samples observations, means is 4.1 and means for Y is 3.5. Provide the following information. Oh, I made a mistake. So random samples of observations on both variables, each of sizes 2. So random samples the question says that random samples of observations on both variables of observation of both variables let me do minor correction so that you can have all the information. So this read random samples of observations of both variables each of size 12. Each of size 32 provide the difference, provide the following information. So the following information is provided to you. Provide the following information. mean is 4.1. And also the mean for population Y, this one is 3.5. Then we say that estimate the difference between population means made the difference between population means by means of means of 95% confidence interval. So that's the end of the question. Very simple question. Random variables x and y are normally distributed with the standard deviations of random variable x is 1.2 and random variable y is 0.9. Random variable, so this is R. Random variable, this is R. So random variable, and this is continuation. Random variable samples, random samples of observations of both variables, each of size 32, provide the following information, means provided the following information, provided, so let me do minor correction, provided the following informations, means of random variable x is 4.1 and the means of random variable y 3.5, estimate the difference between the population's means by the means of 95% confidence interval. So the formula is this, everything is there, just solve it and enjoy the beauty of life of engineering mathematics. And then after you solve it, you'll join me in the next concept where I'll be start teaching you about confidence interval estimate for a population mean when the variance is what? No, I will teach you about the estimations of the difference between the means when the population variance are unknown, because this is when the population variance is known. So thank you very much. I thank God for being with me from the beginning, from the preparations of this lecture for statistics, for the course of statistics for non-measures. I would like also thank God for you who have been taking or have been learning these contents from the beginnings to the end. May God bless you abundantly. I would like just to remind you that enjoy the beauty of engineering mathematics. Tell us in the comment sections you enjoyed this material. From which continent? From Africa, from North America, from South America, from Europe, from Asia, from Australia. Anywhere in the world, tell us that which continents are you from. And then tell us that which country are you from. Are you from Namibia? Are you from Tanzania? Are you from South Africa? Are you from United States of America? Are you from United Kingdom? Tell us in the comment sections and tell us that which institutions you are pursuing your undergraduate studies or in which city. You can tell us in which regions. If it's Tanzania, tell us that in which regions, in which institutions, or in which college, or in which universities. And let's ask many questions as well as we can about what I've taught you in the comment sections. I'll try my level best to go through. Remember that OLENJOLAI does not know everything about the statistics. I just know a small portions of it. And I'm ready to share the contents or the concept that I know about statistics with millions of students in this present generations and even future generations. So I'm still learning a lot of things about statistics because it's very important for my life, my daily life, and even for the rest of my life. So stay tuned and then join me in the next lecture of lecture 3. Make sure that you share these contents or materials with your colleagues, because this can take these materials anywhere and at any time. So if you have any comments or any suggestions, please let us know in the comment sections, read also the descriptions, and also you can visit even our other YouTube channels that you can enjoy the beauty of engineering mathematics, the beauty of science, and even later on studying the beauty of engineering, especially for electrical and electronics engineering. So thank you very much. May God bless you. May see you in the next lecture. May God bless you and keep you for the rest of your life.